All right, so fourth unit of our class together, we're going to talk about a new mathematical object for us. Again, I don't assume that you've seen this before. You might have if you had a pretty thorough algebra teacher in high school. We're going to talk about these things called rational expressions, and the reason we bring these up now is these have a lot of application for us when we get to college algebra, pre-calculus. We talk about a lot of ratios like this. In college algebra, we talk a little bit more about the behavior. What we're going to deal with today is just kind of the basics on how to work with these things so that when we are looking at their behavior, we know how to manipulate these things called rational expressions. So what is, first off, a rational expression? That would be a great question if you don't know what they are. Rational expression is defined as the quotient Q-U-O-T-I-E-N-T. I know my writing was a little messy there. It's a quotient of polynomials and has the general form of a polynomial in the numerator and a polynomial in the denominator. These letters P and Q, they just represent polynomials. Let me just make a little note. Okay, each of those just a polynomial, like the things that we were factoring in the previous chapter. And that's why we now go on to this, is because factoring is going to be kind of an instrumental tool for us to be able to work with and manipulate. And there is one limitation. The polynomial on the bottom can't be zero. Okay, just like any fraction that we have, dividing by zero is something that's not defined. So just a couple of examples of rational expressions just to kind of to get your feet wet. So if we have something like 5x plus 4 divided by x squared minus 8, okay, that's a rational expression. We've got a polynomial on the top, polynomial on the bottom. Here's another one. Let's say I have x squared plus 9x minus 5 divided by, let's just say x cubed, something like that. That is another example of a rational expression. And we could sit here all day, and you can see on the 4 pages that we have to go through today, there's lots of examples of irrational expressions. Okay, so this thing right here where the denominator can't be zero, this is going to introduce us to something we talked about way back in our second unit when we first started talking about functions. One of the pieces of terminology we had with functions was what was called the domain and the range. Does anyone remember what the word domain refers to? The x values, yeah, okay, so that's a little bit of the way back machine. So that's long-term memory here. So the domain of a rational expression includes all the numbers except anything that makes the denominator zero. So the domain is everything, every real number you can imagine, except anything that makes the denominator zero, we have to leave out. Okay, so if that sentence is a little long for you, what I'm trying to communicate to you there is that when I communicate to you the domain, we leave out anything that makes the denominator zero. Everything else works just fine. So what we're going to do first, as we get used to working with rational expressions in this class, is we are going to find the domain, some rational expressions, and we're going to revisit writing things in interval notation like we have before. So the first example right there is my example. We're going to find the domain of this. X plus 1 in the top, x minus 8 in the bottom. So finding the domain means I'm going to find all the x values that will work in this. And so what my process is, again, just to repeat what I've already said, the process is we find what doesn't work and we leave them out. So the only thing you have to pay attention to in this, don't be distracted by the numerator. The numerator doesn't impact the domain at all. All you have to worry about is what's in the bottom. Okay, what is in the denominator? Because that can't be zero. We don't know how to divide by zero. Just to prove it, take your calculator if you want to and put in 9 divided by 0, and the calculator is going to go, I have no idea what to do. It's going to give you a little error message. So here's what you do in all these problems that we're going to go through here. You're going to take the denominator, whatever it is. This one's x minus 8. I'm going to say, okay, what makes that 0? Because those are going to be the values to avoid. Well, that's an equation that we've been solving since the first day of class. Just a cute little linear equation. I'm going to add 8 to both sides of this. Okay, I'll write the work. If you don't need to write the work, don't write the work, that's fine. I'm going to add 8 to both sides of this, and I get, okay, when x is 8, that's a problem. Because when x is 8, my denominator here is 8 minus 8. That's 0. Oh no, I can't have 0 in the denominator. So what I need to do now is I need to write my domain, and I need to communicate to everyone that I can use any number except for 8. 8 is the problem. So here's how we do this. Okay. The way that I write all real numbers is, again, this is the Wayback Machine. This is when we talked about interval notation in, I think it was in section 2.4. What I'm going to do is I'm going to write negative infinity. I'm going to leave a big space here, and I'm going to positive infinity over here. That's all real numbers. That's the whole number line. But I've got to communicate to people, hey, I've got to skip 8. 8 is a problem. 8 makes the denominator 0. I've got to leave it out. And so here's how we do this interval notation. We just imagine ourselves going down the number line. So we're coming from negative infinity, and what number do I have to skip? 8. So I'm going to put a comma, and I'm going to put an 8 here. And I'm going to put a parenthesis because we're not going to be equal to that. So what we're saying is, oh, there's a bump in the road right here. I'm going to use a little U here. This means union. This is how we link intervals together. We're saying both of these intervals are the domain. And then I'm going to put another parenthesis, and I'm going to say, okay, 8 infinity. And so it looks a little bulky. I understand the first few times you do it, it seems like a lot of writing. But what this is saying is I can go all the way down from negative infinity to 8, and then I've got to jump over 8, and then I can go from 8 to infinity. Okay, so that's how you write I'm skipping 8 in interval notation. Now, I know that's probably new for most all, if not everyone here. So we're just going to practice this for a few problems, writing these domains in interval notation. So exercise 1 right next door. It's essentially the same problem. I'm going to give you 90 seconds. Figure out first what value does not work. Okay, what do we have to leave out? And then practice writing that in interval notation. All right, first thing I want you to tell me is, how did you figure out what X value does not work? What did you do? Yeah, perfect. Both of you are communicating the same thing. I appreciate that. Take the bottom, okay? I don't care about the top. The top is just the distraction here. I take that bottom, X plus 7, and I say, okay, when's that 0? That's the problem. So yes, just like Roderick said, I'm going to subtract 7 from both sides. I'm going to get X is equal to negative 7, perfection. So if you've got that, you're doing great. The rest of this is now remembering interval notation. So the domain is going to be all the numbers from negative infinity. I'm going to leave a gap, positive infinity. And now I just have to say I need to skip over negative 7. So negative infinity, comma, negative 7, parentheses, and then negative 7 to infinity. So any value in those two parentheses I can use. The only thing I skip is negative 7. That's the domain of our rational expression. Exercise 2, same thing. You're just getting another opportunity. So figure out what value does not work, and then write in interval notation what the domain is. So again, denominator is the only thing that's important in this question of what the domain is, because we can't divide by 0 with fractions. That's why it draws our attention. So hopefully what you did is you said, okay, 2x minus 1 equals 0. And what's the x value that you end up with here? 1 over 2, perfect. You add 1 to both sides, and you get 2x equals 1. Then you divide it by 2, and you got x is 1/2. That's the value that we have to skip right there. So now the next thing is I'm going to use interval notation just to let everyone know that what I need to skip is the value of half. So I go from negative infinity to positive infinity. That's all real numbers. And then the value to skip is a half. So we write it like that. All right, before we level up here, anybody got a question, comment, concern? Anything I need to address better than I have? Yeah. That's a great question. So in case you didn't hear, why don't we worry about the numerator? Because I'm just going to come up here where I got a little blank. It's the difference between this. If I have 0 divided by 5 or 5 divided by 0, okay? One of those we can do and one we can't. When you have 0 in the numerator, that's saying you have 0 of something and you want to divide it into 5 parts. So if you have $0 and you're going to give each friend of yours, each of your 5 friends, an equal amount, how much you're going to give them? 0. You don't have anything to give, right? And the way we can determine that is just long division. If I take 0 and I divide by 5, well then 0 times 5 is 0 and everything works out. So 0 in the numerator is not a problem. 0 in the denominator. Well, this is a weirder question. If I have $5 and I want to divide it among 0 friends, how much do I give each? Well, it's kind of a weird question. So now we figure this out by long division. What number up here, I'm going to put a question mark, what number up here times 0 gives me 5? Well, any number that I put up here times 0 is always going to be what? 0. So you can't chip away at this at all. So that's why dividing by 0 is undefined. And that's why we have to focus on the denominator. And that's why we don't have to worry at all about the numerator when we're finding domains. Great question. Hopefully that was helpful. All right, exercise 3. I'm going to let you do exercise 3. It's the same question we've been doing, but notice x squared minus 25. I have something from last chapter. So just to give you a little hint, when you set this equal to 0, you're going to have to factor it. Okay, it's a difference of squares, and you're going to come up with 2 values. Okay, and then make a guess on how to write that in interval notation. And if you don't quite get it, that's okay. It's your first one. All right, so we're going to take the denominator of this, the x squared minus 25. We're going to say, okay, I need to avoid when that is equal to 0. Well, how does my difference of squares here factor, x squared minus 25? Awesome, outstanding. My firsts are x and x. My lasts, what give me 25, are 5 and 5. And since I have no middle stuff in here, I'm going to put a plus here and a minus there. Okay, we spent some time factoring differences of squares in section 5.3. So now we have 2 things we have to avoid. I have to avoid when x plus 5 equals 0. I have to avoid when x minus 5 equals 0. And so that means that x negative 5, x positive 5, those are the values that are bad. They're going to make the denominator 0. So hopefully you got there, because that's just a review of what we did the last unit. Okay, so if you're still struggling with that, then like I said, factoring is going to come up over and over as you go into this class, and then beyond. When you take college algebra, there's factoring is just kind of a known commodity now. So now writing it in an interval notation. Okay, now this might be the part if you didn't quite get this, if you made a hypothesis, that's okay. Well, let's see how you did. So again, I've got negative infinity to a positive infinity. And as I'm strolling down the number line from negative infinity, which value do I hit first? Negative 5 or positive 5? Yeah, you hit negative 5. And now here's the part that you might have forgotten. I understand because I didn't do one for you yet. So if you didn't put this part in, I get it. Now we have to show that there's values between negative 5 and 5. So I'm gonna put a little set of parentheses here from negative 5 to 5. And then I didn't leave myself enough room. I apologize. So I'm going to just scrub that out right there. So union, and then from 5 to infinity is the third. So there's 3 intervals. There's negative infinity to the first value I can't use, which is negative 5. There's all the values between them, between negative 5 and 5. And then I have to skip 5. So now the third interval is 5 to infinity. So I understand that that's new stuff right there. You've probably never written something in interval notation like that. So that's why we're going to do one more of these just to make sure we reinforce that. So exercise 4 is another one with a quadratic in the denominator. So you're going to have to factor that to figure out what values you're not going to use, and then write it in interval notation. All right, here goes. I'm going to get started with the factoring. If you're still working, keep working. But I'm going to take the x squared minus 2x minus 35. I'm going to set that equal to 0. There's a 1 in front of the x squared. So this is just the simpler of the factoring examples where I'm just going to unfoil. So here's my parentheses. My first, what's the only thing that can give me x squared? X and x. Since my 35 is negative, my lasts are negative. That means my signs have to be what? Positive and negative, one of each. And then they have to add up to a negative 2. So that means I'm going to use a positive 5 and a negative 7. Because positive 5 plus negative 7 gives me negative 2. So that means here's my first possible answer. My second, the first one's going to be x equals negative 5. The second one is x equals 7. Those are the 2 values I have to skip, because those are the 2 values, if you took the time, if you had the time to plug them back in, they will give you 0 in the denominator. Can't divide by 0. So my domain, here we go. We're starting at negative infinity. And what's the first value that I have to hop over? Negative 5. Yep. And then negative 5. And then the next one is 7. Got to skip over. And then there's no others. We were in a pre-calculus class and we were looking at something that maybe had more things you could skip on the bottom. You can do that as many times as you have to, but in this class, that's going to be pretty much the extent of it. So you don't have to worry about really beyond that. So that's the domain. Please practice that. Practice writing things in interval notation. That way, when I'm going to put a problem, one of each of these. I'm going to put one with a linear thing on the bottom. I'm going to put one with a quadratic on the bottom. Those are test questions right there. Put an asterisk by them. Okay, that's going to be on the test, I promise you. All right, next thing, as we're getting to know these new things called rational expressions. We always want to write, you know this, you had some teacher in fourth or fifth or sixth grade, whenever you're talking about fractions, and he or she told you need to reduce your fractions, always, and that's what you get told to do. So for instance, example 2, this is my example right here. Okay. What does it mean to reduce a fraction? Or we sometimes say we're canceling something. What does it mean to do? Well, here's what somebody at some point in the past hopefully taught you. Okay, we never write all this down. We just assume, and we have shortcuts to do this. But here's what you're doing. What's the common factor between 10 and 25? 5. And so here's what you do. Okay, 10 is 2 times 5, and 25 is 5 times 5. And again, we don't ever write this. Okay, at some point you learn it, and then you just move on and you take a shortcut. But here's what canceling is. What's 5 divided by 5? 1. Okay, so you no longer see it because it becomes 1, and anything times 1 is just 1. So that's what canceling is. Canceling means find a factor that's the same in the top and the bottom, and that equals 1. And what we end up doing instead of writing equals 1 is we just cross them out. It becomes canceling. And so then the factors that are left, we've got a 2 in the top and a 5 in the bottom. That is reducing our fraction. Okay, so we can do the same thing with example 3. Okay, and we're going to do the same thing with example 3. And I told you as we were going through the last unit, factoring was going to be a big deal in this unit because it's going to be how we reduce and how basically the whole rest of our time together is going to be factoring and reducing today. Okay, so if factoring didn't quite stick before, well, we're going to do plenty of it today. So x squared minus 49, that's a difference of squares. What are my two factors going to be for x squared minus 49? Boom, yes. All right, x plus 7 and then x minus 7. Great job. Yep, it's a difference of squares, so be sure to change those signs in there. And then in the denominator, we have a trinomial with a 1 in front of the squared term, so I'm going to unfoil it. So x squared is x and x. The positive 14, the positive in front of my lasts means what are my signs going to be? They're both going to be positive. And then the two factors of 14 that add up to 9 are 2 and 7, or 7 and 2. Doesn't matter what order. Okay, I'm going to give you a second to catch up to me. And then here is the one other step. We got one more thing to do to reduce this. Do you see a factor that's the same in the top and the bottom? X plus 7. So now I can cancel those out, just like we did over here with the 5s when we reduced 10 over 25. So x plus 7 is gone. And here's what my reduced fraction is. I've got x minus 7 over x plus 2. Now, I don't want you to write this down, but I just want to address this because I know a lot of you are thinking it because I've taught this class before. Some of you are thinking, oh, hey, Perkster, we've got x minus 7 over x plus 2. I just want to cancel those x's now. I just want to, now I have negative 7 over 2. That's my answer. And the reason you cannot do that is these things in the numerator and denominator are not being multiplied together. This is x minus 7. That subtraction sign means these two things go together. They are all one thing. And then the x plus 2, those go together. You cannot cancel terms. Okay, so make a note to yourself if that would have been your temptation. You cannot cancel terms. You can only cancel things that are being multiplied together. And that's why x minus 7 over x plus 2, that is the correct final answer. Don't take it too far by doing things that are mathematically illegal. All right, flip the page. Now it's finally your turn. So exercise 5. Just to give you a little nudge, the top has a common factor and the bottom you're going to unfoil. And then you're going to see if there's anything in common and reduce it. So in the top of this, we've got 3y squared minus 6y. What's the factor those two things have in common? A 3 and a y. Yep. And when you start off with 3y squared and you take out the 3 and the y, you're left with another y plus the 6 divided by 3 is 2, and we took the y off that term, so I don't need it. So we have 3y times y plus 2. Those are our two factors. In the bottom, I have a trinomial. I have a 1 in front of the squared, so I'm just going to unfoil it. Y squared is y and y. You told me on the last problem, under these conditions, when I have a positive here, that my signs are going to be positive. And then the two factors of 6 that add up to 5 are what? 2 and 3. Perfect. Do I have something in common that I can cancel or divide out, however you want to phrase that? Yeah, the y plus 2. Boom, boom, they're gone. And I just left with a 3 times y in the top and a y plus 3 in the bottom. And again, I can't cancel those 3's because the 3 in the bottom is linked together with the y by a plus sign. Okay, so I can't go any further with that, even though the temptation is there. Exercise 6. Just some unfoiling, and then you're going to cancel out the factor that's in common. I've just got a bunch of examples here because I want to practice factoring. I want to get you comfortable with fractions because I know we hate fractions. So we're just going to go through a bunch of these. So the top of this, we're just going to unfoil both of these. They're both trinomials with 1's in front of the squared term. So in the top, got x and x. The last time we had a negative in front of our last, that meant the signs were 1 of each. And then the two factors of 20 that are 1 apart are 5 and 4. So the 5 gets to be negative, the 4 is positive because they add up to a -1. In the denominator, we just factored something super similar to this. The two factors of 8 that are going to add up to 6 are 2 and 4, or 4 and 2. Does not matter what order you put those in. And then I think once you get it factored, it's pretty clear. Oh, there's x plus 4s on the top and the bottom. That's great. So we cancel those out. And here's my reduced fraction, x minus 5 over x plus 2. One of the benefits you'll see when we get to college algebra and we do things like graph something like this, because that's a lot of fun looking at the behavior of this. It's a lot easier to graph this reduced thing than to graph the beginning thing. So we always want to make sure we got things reduced. All right, exercise 7, it's just another problem, common factor in the top and the bottom. So go ahead and give that a try. Reduce it, please. in the numerator of this, the 10r squared minus 40r, what's the common thing between those? Yeah, 10 and 40 share 10. And then I've got r squared and r, so r is also in common. So again, 10r squared, I took out 10 and one of the r's, so that leaves me the other r, minus 40 divided by 10 is 4, and I took out the r, so I don't need to add another one. So I've got 10r times r minus 4. The bottom, what's the common factor between 6r minus 24? 6, yep. And 6r, when I factor out the 6, leaves r, and then 24 divided by 6 leaves 4. The reason I gave this problem is there is one common thing in the top and bottom that I think is in our face. It's obvious. The other one you might have missed, so I just want to make sure we're looking for the detail. What's one of the things in common here? Yeah, the r minus 4. That's the one that's kind of staring us in the face. You can't help but see that one, r minus 4 and r minus 4. There's something else in common to the top and the bottom. Yeah, 10 and 6 have a common factor of 2. Okay, so I can cancel out 10 and it becomes 5, and then cancel the 6 and it becomes 3 because I took out a common 2. And so now what that leaves me is I've got a 5r in the top and I've got a 3 in the bottom, and now that's fully reduced. Exercise 8, the reason I've given you exercise 8 is, again, part of my premise for today is we're reviewing and practicing our factoring. So I just wanted to remind you, we've got a sum of cubes in the bottom. Okay, so give that a try. See if you can recall how to deal with a sum of cubes, and then cancel the common factor. All right, so the top is a difference of squares. In fact, I think we've already factored that on the front of the page, or something real similar. So x squared minus 25 is x plus 5, x minus 5. The bottom, this might have been a little more of a struggle to remember because I know it's been a few days since the test. So remember, our sum of cubes has 2 factors to it. The first factor is just the cube root of each term. So what's my first going to be of this first factor? X, and then what? Perfect. Yep, plus 5. Okay, cube root of each. And then the way I showed you, the pattern I showed you in class, and you are welcome to adjust this, however, is I like to do the firsts, the lasts, and then I do the middle part at the end. And so the firsts is, okay, I had x cubed. I factored out x. That leaves x squared. I had 125. I factored out 5. That leaves 25. And then the way you get the middle term is you take each of these 2 terms, the x and the 5, and multiply them, get 5x. And then you change the sign to minus 5x. Same pattern every time for a sum or a difference of cubes. It's just a matter of getting used to doing that. And so now once we've done that, the x plus 5 is what's in common in the top and the bottom. The rest of that is all terms, and so I can't do anything else. So my numerator is x minus 5. The denominator is x squared minus 5x plus 25, and we're done. That's all there is to that problem. All right, one more reducing problem, and then we're gonna level up. We're almost done with the new situations here. The reason I give exercise 9 is what you're going to see happen is what's in the numerator cancels with something in the denominator, and so the it's not a problem, but the thing that I want to point out to you is what to do when your whole numerator cancels. Okay, so give the problem a try. All you have to do is factor the denominator, and we'll talk about that. Okay, so the only thing to factor here is the denominator, which is a difference of squares. So x squared is x times x, 16 is 4 times 4, and then plus 1 minus the other. And again, there's a common factor. Great. Okay, not too big of a deal, I don't think. But here's what I wanted to point out. What's left after I cancel? X minus 4. Where is the x minus 4? It's in the denominator. So what I have to do, even though I've canceled out what's in the numerator, I got to put a 1 there, okay, to hold the place, because that x minus 4 is in the bottom. Okay, so the proper answer here is 1 over x minus 4. So sometimes students, when the whole numerator cancels, will just write x minus 4, but that's a completely different thing. Okay, so it needs to be 1 over. Okay, once you see that, hopefully you remember, just make sure the position of the factor that's left over does matter. This next example I'm going to do, in all honesty, I wouldn't even do it if our book didn't love this problem so much. I don't know why our book has such a fondness for this. But notice this problem right here. I've got an x minus 3 in the top, and I've got a 3 minus x in the bottom. What's true about the x terms? I've got a positive one here, a negative one here. What is it called when the sign's different? Anybody remember? Probably asked that question. I could have asked it better. How about the 3's? How do the signs relate on the 3's? They're opposites. There's the word I was looking for. Thank you very much. The signs on the 3's are opposites. The signs on the x's are opposites. So what I have here is I have two factors that are just opposite signs. And here's what I'm going to do. I'm going to show you what technically, mathematically is happening. You can choose to write it down or not write it down. That's fine. And then I'm going to show you the shortcut, what I expect of you, okay, when you see this. So if it pops up on the homework, you can just skip right to the end of this. So mathematically, the way you take care of this is what I'm going to do is I'm going to factor out a -1 out of the bottom one. And when I factor out a -1, I'm also going to reverse the order of the terms. A negative x divided by a -1, a negative divided by a negative is a positive x. A 3 divided by a -1, a positive divided by a negative is a -3. So those two things just are opposites. They differ by the sign. Now I can cancel the x minus 3's. And I have 1 divided by -1. And that is just going to equal -1. So here's all I expect of you ever. Okay, I don't expect you ever to do that for me right there. I just wanted to show you what's going on. If you notice in any problem that you have opposites in the top and the bottom, all you have to do is skip over and you can say, okay, that's equal to -1. Okay, those two things are opposites. All right, before I flip the page, are we doing all right? You see, it's just a lot of factoring that we're practicing here. So we're going to keep practicing. All right, I'm flipping the page. Okay, the last thing we're going to remind ourselves about is when I have fractions, multiplying and dividing them. And again, it's just a little bit more factoring. Okay, so it's the good times are going to keep rolling along right here. So here we go. Example 5 is my example. I'm going to do this one along with you, and then you've got several that you're going to do. So the nice thing about multiplying and dividing is there's very little actual multiplying and dividing to do. It's mainly just factoring and reducing. So for instance, I've got these two fractions. I've got this x squared plus 2x minus 15 over x squared minus 4x plus 3. And then that dot there means I'm multiplying times this fraction over here. And I'm not going to read it out to you. You can see it for yourself. And so here's what we're going to do first. Before I even worry about what it means to multiply the fractions, we're just going to go through the 4 numerators and denominators, and we're going to factor them. Okay, so here goes. More practice. In my first numerator, x squared is x and x. Okay, it's the same questions every time. Hopefully we do the rest of this, and they're going to be echoing in your head. The 15 is negative, so that means my signs are going to be positive or negative. And then the 2 factors of 15 that are 2 apart are going to be plus 5 and minus 3. There we go. We're off to the races. That's our first one. The denominator. X squared is again x times x. My 3 is positive. So what does that tell me about the signs in the 2 factors this time? They're going to be the same, and in the past it's been positive, but this one, the 4 is negative. So that tells me they're both going to be negative this time. And then the 2 factors of 3 that are going to add up to 4, well, 3 doesn't have a whole lot of choices. It's going to be 1 and 3. Times x squared minus x has a common factor. What's the factor in common to those 2 terms right there? Yep, an x, always the lowest power. So x squared, when I factor out an x, I have an x left over. Negative x, factor out the x, you got minus 1. The denominator, x squared is x and x. The 20 is negative. That tells me the signs are 1 of each. And the 2 factors of 20 that are 1 apart are 5 and 4. So I'll give you a second to catch up to my writing. I've tried to keep the factoring pretty straightforward. On the MyMathLab, the factoring on these should be pretty straightforward, okay? Because I know we're talking about a new thing in rational expressions. So I don't want to conflate the 2 skills. And now what we do here is I'm just going to cancel out what's in common to the numerator and denominator. And here's the thing to remember. When you multiply fractions, you always multiply straight across. So all of this is my numerator. It doesn't matter that they're on different fractions. Since I'm multiplying, this is all the numerator. And all of this is the same denominator because we're multiplying. And so I can cancel out anything in the numerator with anything in the denominator. So what's something that they have in common? Okay, yeah, x minus 3, boom, that one. What else? X plus 5, gone. X minus 1, great. Very satisfying to do all that canceling. And so then all that's left in the numerator is that x, and then all that's left in the denominator is the x minus 4, and we're done. Nothing else to do on that problem. Then we did enough work. We wouldn't want to do anything else. All right, exercise 10. I've just given you something. Actually, there's only 2 things to factor there. Okay, so I just tried to reduce the work a little bit on this first problem. So exercise 10, factor what you can, and then cancel what you can. All right, let's see how you're doing. So as I'm going through this, the 8t squared, that's just a term. So 8t squared. The denominator, t squared minus 4, that's a difference of 2 squares. So that's t plus 2 and t minus 2 times 3t plus 6, I can factor out a 3 out of those two. So 3t when I factor out a 3 is t. 6 factor out the 3 is plus 2. And then the 9t, that's just the term. So there we go. So there's the factoring step. That's drawing on what we did in the last unit, and we're practicing and getting used to it. Now here's the new thing. Since I'm multiplying those two fractions, I'm going to simplify this. And so I noticed there's a t plus 2 in common, so I can get rid of that. What else is in common to the top and the bottom that's a little less obvious than that? I'm sorry? A t? Yes. I've got two t's in the top, and I've got one t in the bottom. So I'm going to cancel this t right here with one of the t's. So I'm just going to cross off the squared in the top. There's one other thing in common. Three and the 9. They both share a 3. 3 goes into 3 once. 3 goes into 9 3 times. Yeah, I know those multiples are a little less obvious. And so now what's left in the top is just the 8 and the t that was left over from canceling. So the 8 and the t. And then in the denominator, I have a 3 and a t minus 2. You are welcome to remultiply that, but that's just extra work. So I recommend not doing it. Why do more work than you need to? But if it makes you feel comfortable, you can multiply the 3 times the t minus 2 and get 3t minus 6. Either way is fine by me, but I do as little work as possible. All right, exercise 11. Exercise 11, just more factoring, then reduce. There's two of those. Two of those you're going to unfoil. Two of those have common factors as you're going through and factoring this problem. I'll say, okay, so just going through this factoring right here, the first numerator, there's a common x. And so when I factor out the x, that leaves x plus 2 in the parentheses. The denominator is x squared minus 4, which we factored that in the previous example. So that's x plus 2, x minus 2. The next trinomial, when I unfoil it, the firsts are x and x. Since this is a positive 4, that tells me the signs are the same. And the negative here tells me they're both negative. So the two factors of 4 that add up to -4 are -2 and -2. And then the last one, a common factor of x. And when I factor out the x, there's an x minus 1 in parentheses. So there's my factored expression right there. And you can see there's a bunch of things that I can go ahead now and divide out or cancel or cross off, whatever you want to say. So x plus 2's go, this x minus 2. Now you can only cancel 1 for 1. So this 1 x minus 2 goes with one of those. Doesn't matter which one, but you can't cancel both of them out. And then last but not least, this x right here and this x right here go. So when all the carnage is said and done, I've got an x minus 2 in the top and I've got an x minus 1 in the bottom left over. If you have any questions while we're doing the next problem, raise your hand. I'll come to you. I'll help you any way I can. Okay, I'm happy to do that and be of service to you. Exercise 12. Exercise 12 has a couple things that have a common factor. There's a difference of squares, and there's one thing that doesn't need to be factored at all. So on this one, the first numerator, x squared plus 2x, there's an x in common to those. And so when you factor out the x, you have x times x plus 2. The denominator is x plus 1. That can't be factored at all, so I just leave it. The next numerator, x squared minus 1, that's a difference of squares, so that factors to x plus 1 times x minus 1. And then the last denominator, x cubed plus x squared, they have two x's in common, so x squared, and then that leaves x plus 1. So just like the other problems, from here on out, it's just noticing what is the same. So I've got an x plus 1 in the top and the bottom. It doesn't matter if you cancel this x plus 1 with the other one. Just pick one and cross them out. This x right here can cancel with one of the x's right here. So I'll cross off the exponent. And that's it. And the reason I gave this problem is once you've finished that, don't go to any effort multiplying. Just write your problem like this. X plus 2 times x minus 1 is what's left in the top. And then I have x times x plus 1 in the bottom. Don't go to any more work. Don't FOIL. Don't distribute. No need to. It's just extra work. This right here is perfectly formatted and looks nice. Exercise 13, more of the same. right, so going through this factoring, the first trinomial is m squared plus 2m minus 15. Since that 15 is negative, that tells me the signs are one of each, a positive and negative. And then the two factors of 15 that are two apart are going to be plus 5 and minus 3. The denominator, m squared minus 5m plus 6. Since this 6 is positive, that tells me the signs have to be the same. And since the 5 is negative, that tells me they're both negative. So the two factors of 6 that are going to have the 5 are -2 and -3. The next one is a difference of squares. So that's m plus 2, m minus 2. And finally, we've got a common factor of m in this denominator. So when I factor out the m, I have m times m plus 5. So there's everything factored, and now we'll see what's in common. And so the m minus 3s are in common. The m plus 5s are in common. Get rid of those. The m minus 2s, so almost everything goes away. The only thing that's left is in the numerator, I have an m plus 2, and the denominator an m. And again, resist the temptation I know we all have to cancel out those m's because the one in the top is linked with the 2. They go together. When things are added or subtracted, it's all or nothing. All right, exercise 14. One more multiplication problem, and then we got just a couple more problems after this. You're doing great. I appreciate your endurance. We're just about done. I'm just going to get started factoring. So if you're still working, keep working. Okay, the first numerator is a difference of cubes. And so I've got my two factors. My first factor is just the cube root of each. So it's going to be p and then -3. And then my second factor, the first, is going to be p squared because I started with p cubed, factored out p, so I have p squared. My lasts, I started with -27, factored out a -3, so that's +9. And then the middle, p times -3 is -3p, and so I changed the sign to +3p. The denominator of that one, I'm just unfoiling. So p squared is p times p. The 12 is negative, so that tells me the signs are one of each. And then the two factors of 12 that are one apart are +4 and then -3. The next numerator, p squared is p times p. The 24 is negative, so the signs are one of each. And the two factors of 24 that are two apart are -6 and +4. And then last but not least, unfoiling again, p squared is p times p. And then the 6 is negative, so that tells me the signs are one of each. And then the two factors of 6 that are 5 apart are -6 and +1. So notice on those last three, the denominator and the numerator and denominator of the second fraction, it's the same questions you ask yourself, the unfoiling questions. You figure out what the signs are, and then you pick the pair of factors that meets the constraints of the middle. Once you've done that, we see the p-3s are going to cancel, the p+4s are going to cancel, the p-6s cancel, so lots of canceling going on, very gratifying. And so all that's left, your reduced multiplied fraction. The top is p squared plus 3p plus 9. And then the bottom is p plus 1, and that's it. There's nothing else I can do. There's nothing else I'd want to do. You did plenty of work on that problem. All right, we're going to flip the page. We're almost done. I got one more problem. You've got two more, and then you're free of me for another day. The only difference now when I have division. Does anyone remember? I know we like to block fractions out of our brains, so you might not remember. Does anyone remember what you do to divide fractions? Yeah. You flip them and multiply. Yeah, you flip the second fraction and you multiply. So what I'm going to do on this problem, as I go through my factoring, I'm also going to flip the second fraction and change it to multiplying. So these problems are just like what we were doing. That's why I put fewer. I figured you're probably exhausted by now anyway. So 8x minus 16, they have a common 8, so I'm going to factor it out. So 8x, factor out the 8, leaves x. -16, factor out the 8, that's -2. 3x is just a term. And now here's what I'm going to do. I'm going to change that division to multiplication. And now in the second fraction, I'm going to flip it. So the 4x squared that's in the bottom is going to come up to the top. And then the 3x minus 6 is going to be in the bottom. And I'm just going to factor that as well. So I'm going to factor out the common 3. And 3x, when I factor out the 3, leaves x. -6 divided by 3 leaves -2. Okay, so flip the second fraction and multiply. You never flip the first fraction. You always leave the first fraction alone. Once I've done that, I can now cancel the x minus 2's. There's one in the numerator, one in the denominator. I can cancel an x in the bottom with one of those x's in the top. And that's about it. So all that's left in the top is the 8 and the 4x, and 8 times 4 is 32x. And then in the bottom, I've got 3 times 3, and 3 times 3 is 9. So there is my, there's the result of my division. So example 15, there's a few more things to factor. Make sure you flip and multiply by that second fraction. I'll give you a couple minutes to sort out that factoring. So let's knock this one out, and then there's one more to chew on, and then we'll be done. So the first numerator, I can factor out an x. So x squared, factor out the x, leaves me x. 3x, factor out the x, leaves me 3. The first denominator is just x plus 5. There's nothing else to do there. It's a division problem, so I'm going to change it to multiplication. And the x squared minus 9 that's in the top is now going to go in the denominator. So when I factor x squared minus 9, it's a difference of two squares. So x plus 3, x minus 3. And then the 3x minus 9 that was in the denominator is going to move upstairs. And so I'm going to factor out that 3. And 3x, factor out the 3, leaves me x. And then negative 9, factor out the 3, leaves me negative 3. And now once I have changed it to a multiplication and I have flipped it, there's a couple things that I can go ahead and cancel. The x minus 3s, the x plus 3s. There's nothing else. That's it. And so what that leaves me in the top is the x and the 3. So that's 3x. And then the bottom, just the x plus 5 is what that turns out to be. All right, one more problem. It's the only problem that I've given you today that has one of the things, has a number in front of the x squared. So you've got to use either the grouping method or whatever else. The rest of it is stuff you've already seen today. So probably most of your time will be factoring the first numerator. So I'll give you a couple of minutes and then we will roll to the finish line. Right, just for the sake of time, I know that this one, when you have a number in front of the square, they take a little longer. So apologize, not meaning to make you feel rushed here. So we're going to factor this. So again, the way I showed you in class, there are other ways to do this, but the way I showed you in class is we're going to multiply this first number times the last number, the 2 times the negative 6. That gives us negative 12. Since the 12 is negative, that means I'm going to have a positive factor and a negative factor. That's how you get a negative number. And I need the two factors of 12 that are going to be 1 apart. That's where I use this middle number. That's a negative 1. So I'm going to use negative 4 and positive 3 as my two values. What we did with those values in this class is we use those as new coefficients to break this middle term into two terms. So that becomes 2x squared plus 3x, then minus 4x, minus 6, And again, if you did this, this is something I said when we went through this. If you did this and you put the negative 4x first and the plus 3x second, that's fine. It'll all work out the same. Okay, so don't erase if you did that. And now the reason we've done that is we're going to factor by grouping. When you have 4 terms, you look at the first 2 terms, you look at the last 2 terms. The first 2 terms, they share an x in common. 2x squared, factor out the x, leaves 2x. 3x, factor out the x, leaves 3. The second pair of terms has a 2, and not only that, they're both negative, so I'm going to factor out a negative 2 out of both of those. So negative 4 divided by negative 2 leaves positive 2x. Negative 6 divided by negative 2 leaves plus 3. And what we always hope to see when we factor by grouping is that the grouping worked. I have the same exact thing in parentheses, so that means I can factor it out. And then what's left from the first term is the x, and what's left from the second term is the minus 2. Okay, so that takes a little time. That's why it's the only one I put on there today. But on your homework, there'll be a couple problems that have a number in front of the x squared. It gives you good practice time. And so 2x plus 3 times x minus 2, that's the first numerator. The rest of these just unfoil. There's a 1 in front of the squared term. So x squared is x times x. The 30 is negative, so that tells me there's going to be 1 of each sign. And the 2 factors of 30 that are 1 apart are plus 6 and minus 5. The next numerator is a difference of squares, which we've done several times on this page because they're nice and quick to do. So it's negative 4, so that's plus 2 and minus 2. And finally, x squared plus 8x plus 12. The 12 is positive. It tells me the signs are the same. And since the 8's positive, that tells me they're both going to be plus. And the 2 factors of 12 that add up to 8 are 6 and 2, or 2 and 6. The order is unimportant. And so now I just go through. I cancel. Oh, I did one thing wrong. What did I do wrong, everybody? I was just so excited to be factoring, wasn't I, that I forgot to flip. Sorry about that. So all of you, I'm sure you did that. So I appreciate that. So I got to put the x plus 6 and the x plus 2 here, and the x plus 2, x minus 2 here. So that was wrong. I apologize. Sometimes you just get in the zone. All right, and now I'm going to go ahead and cancel. So x minus 2's cancel, x plus 2's cancel, x plus 6's cancel. That's great. And I have 2x plus 3 left in the top and x minus 5 left in the bottom. And that is that.